People usually assume the most reliable cars are the best cars. That if a car rarely breaks, it must also be the safest, smartest, and most advanced choice. But what if prioritizing reliability above everything else actually changed the automotive world in ways we never intended? Imagine a world where cars barely evolve for decades, not because we ran out of ideas, but because we refused to risk breaking what already worked. Think about your smartphone. It's one of the most reliable devices you own, until the screen cracks or the battery degrades. Then it's effectively a brick. Now compare that to older technology, clunky, limited, but endlessly repairable. This is the tension between functional reliability, it works perfectly until it doesn't, and mechanical resilience. It's never perfect, but it always runs. Today, we're going to explore why reliability isn't always the safest idea in the long run, and what that trade-off really costs.
When people talk about reliability today, they usually mean a car that doesn't fail, doesn't strand you, and doesn't demand attention. And that sounds like an obvious goal. But reliability is not the same thing as innovation. It's not the same thing as safety, and it's not the same thing as progress. In this video, we're not treating reliability as a bonus, we're treating it as a design constraint. What happens when an entire industry optimizes for reliability first and everything else second? To explore that, we're using the Ford Model T as a case study. Not because it was perfect, not because cars were better back then, but because it represents a very different definition of what reliable meant. The Model T isn't the topic, it's the example of a philosophy we've largely abandoned.
The Ford Model T wasn't reliable because it never broke. It was reliable because it was designed to break in predictable, manageable ways. Henry Ford built this car for farmers, not paved suburbs. In early rural America, breaking down didn't mean calling roadside assistance. It meant fixing the car yourself, wherever you were. That philosophy shaped every engineering decision. Ford used vanadium steel, not to make the car fast, but to make it survive abuse. The engine didn't even use a water pump. Instead, it relied on a thermosiphon cooling system. Hot water rises, cold water sinks. It was less efficient, but a water pump is also a failure point. By removing it, Ford removed an entire category of breakdowns. The transmission used simple planetary gears. When parts wore out, you didn't remove the drivetrain. You opened an access panel under the floorboards and adjusted it with basic tools. Reliability wasn't about preventing failure, it was about surviving it. And that raises the key question: what happens if this philosophy becomes permanent?
When reliability becomes sacred, change becomes dangerous. This is the first major trade-off: stagnation. If a system works well enough and fails predictably, there's little incentive to push it further. Innovation slows, not because progress isn't possible, but because failure is no longer acceptable. Safety improvements are often the first casualty. Simplicity is easy to romanticize, but simplicity has a body count. The Model T had no crumple zones, the steering column was rigid, the fuel tank sat under the front seat. To refuel, you lifted the cushion. In a collision, you weren't protected, you were exposed. Adding seatbelts, disc brakes, or electronic stability systems all introduce complexity. Under a strict reliability-first philosophy, those systems look like unnecessary risks. You cannot radically improve a system that is not allowed to change. Extreme reliability locks designs in place. The consequences extend beyond the car. An ecosystem built around extreme simplicity produces fewer specialized engineers because the technology doesn't demand them. It encourages owner repairs, but also higher injury rates because those repairs lack standards and safeguards. When vehicles last decades with minimal replacement, economic turnover slows, manufacturing cycles stretch, supporting industries grow more slowly. When reliability is optimized for fixability, the system prioritizes stability over evolution. At that point, reliability stops being a feature and starts shaping how fast a society can move. Eventually, the industry made a different choice. The shift accelerated during the 1970s oil crisis. Efficiency suddenly mattered. Carburetors weren't good enough anymore. Fuel injection was the solution. Fuel injection is incredibly reliable. It starts cleanly, runs efficiently, and rarely needs adjustment. But you can't fix it on the roadside with a screwdriver. You need sensors, software, and high-pressure systems. This is when reliability was redefined. Old definition, it will break, but you can fix it. New definition, it probably won't break, but if it does, you can't touch it. Regulations demanded safer cars. Consumers wanted comfort and performance. The result was a vehicle that fails less often, but removes the owner from the equation entirely. Today, when something goes wrong, the problem isn't the failure, it's the lockout.
The Model T wasn't reliable because it never failed. It was reliable because it could always be revived. Modern cars flipped that idea. They are extraordinarily dependable, but fragile in a different way. A single electronic fault can immobilize an otherwise perfect machine. Neither approach is inherently right, but every time we ask for simpler, more reliable cars, we're also choosing slower innovation and fewer new ideas. Reliability isn't a goal, it's a trade-off. If a manufacturer offered you a car today that could last a century, but had no airbags and terrible fuel economy, would you buy it? Probably not. We traded the wrench in the garage for peace of mind on the highway, and we're still deciding whether that trade was worth it.